Welcome to video 13. This one's on ionic solids. Ionic solids are held together by the attractions between the cations and anions in an ionic bond. So, typically, ionic solids look like this, where the red could represent cations, blue the anions, and vice versa. Just basically, you've got a bunch of cations and anions bonded together. Now, keep in mind that anions tend to get bigger and cations tend to get smaller, so it's actually better to draw them like this. This way you can see that there's clearly a bigger one and a smaller one, so anions, cations. Now this is also three-dimensional, so typically you've got, you'd have a red one here, and looking at us building up, you have a red, then a blue, and a red, and a blue, and basically you've got blues surrounded by reds, which are surrounded by blues. The strength of an ionic bond really depends on two things, the charges and the size of the ions, which goes back to Coulomb's law. The strength of the bond increases as the charges increase, which explains why compounds like MgO have a higher melting point than NaCl. Now, on a simple term, magnesium has a 2+, oxygen a 2-, versus 1+ and 1-, which means only one electron is being transferred, thus a stronger bond. If you look at orbital diagrams, however, now, in addition, these compounds tend to be brittle, meaning when you actually apply a force, it comes off in chunks instead of just shattering. When you apply a force, you're pushing cations near cations and anions near anions. They'll push each other away, unless you've got this whole break along this plane, if you will, instead of just a little chunk. Let me show you a picture. So let's imagine this is basically a typical ionic solid. And when I push on it from kind of a downward force right there, here's what happens. This now little section moves down, especially if you actually can kind of increase your force a bit. Now what happens is you've now got blue next to blue. You've got anions next to anions, cations next to cations. Again, the sizes really should be different, but you get the point. And now, instead of being attracted, these are kind of like push each other away. And now you've got two different chunks that you can kind of almost push through, if you will. So they're brittle, as opposed to you push somewhere and all these pop off. It can kind of come off in chunks. Ultimately, the most favorable structure then are going to be those where the cation to anion distances are small and the anion are big, and cation big. So again, kind of what I originally showed you, big blue, small red, all those bonded to each other. Make sure you can draw those. Look at some of the pictures I gave you. That's ionic solids. Thanks for watching.